The process we use for solving inequalities should sound familiar because it's very similar to the process that we use for solving equations. We should try to isolate the variable as much as possible, hoping that all terms will dissolve away from the same side as the variable, leaving us with a simple, single inequality at the end. Here we have a situation where we're going to want to distribute and eventually combine the x's that are already on the same side of the equal sign. The first parentheses gives us 8x minus 16. The second parentheses gives us 10x plus 12. And that will remain less than negative 22. The 8x and the 10x will form 18x. The negative 16 plus the 12 will make negative 4. And we'll finish by adding 4 to both sides, leaving us with 18x is less than negative 18. Dividing both sides by 18 leaves us with x is less than negative 1. Remember, if we want to graphically represent all of the possible solutions of this inequality, we locate negative 1 on a number line, and we shade to the left as all of the solutions are less than negative 1. Careful not to fill in the circle, as we do not have an equal to as a part of our final inequality. In this example, we're going to have to do the same thing we did with equations with variables on both sides. We're going to have to choose a side for the variable and move all of the other terms to the other side of the inequality symbol. I'm going to choose the left side for the variable. If I choose the left side, I'm going to add 14v to both sides. Negative 6v plus 14v is 8v. There's another plus 8. And the negative 28 is still there. I'm going to subtract 8 from the left of the inequality. Now I'm just down to a regular two-step inequality. 8v is still there. Negative 28 minus 8 is negative 36. And we end with v is greater than negative 4.5. Same situation as the last example. We're going to locate negative 4.5 on a number line. We're going to leave the circle open because there's no equal to, and we're going to shade to the right because v is greater than negative 4.5. In our final example for this section, we have a word problem comparing two rental car companies. Now would be a good time to pause the video, read the question, and try to set up the inequality for yourself. If you took the time to set up the inequality, you had a situation where you wanted to ensure that ace was greater than base. The subtle difference in the phrasing of the question to pass the cost of base car rental means we're going to use an inequality. We're not going to use an equation. We don't want them to be the same. We want ace rental car to be more than base rental car. In that situation, here's ace being charged per mile, and we want that to be greater than base being charged per mile. We have variables on both sides of the inequality, so we'll choose a side for the variable. I will eliminate 0.05x from the base side and from the ace side. At the same time, we might as well get rid of the 38. We know that that's going to need to go to the other side of the inequality. And we're left with 0.05x is greater than 4. Dividing in order to finish the question, and we're left with x is greater than 80. Careful with the phrasing of the question. Determine how many miles you must drive for the cost of ace rental car to pass the cost of base car rental. If that's the case, then we want to make sure that we go up to the 81st mile. 80 miles is where we will get equal. 79 won't be enough. We want to go up to the 81st mile. If we can drive parts of a mile, we simply need to go somewhere above 80. So something like 80.01 would even work. That's when representing this on the number line might be helpful.